speed of light. Did you know that light travels at a speed of 3 times 10 to the 8th meters per second? That's pretty darn fast. What is that speed in miles per hour? I've given you one hint on a conversion factor here. You don't need to memorize this one. I would give you this like if it was on a test or a quiz. Still, go ahead and identify what you're given, what your goal is, and then your conversion factors, and then come up with a plan. Here's the plan that we're going to follow. Notice that we've got really complicated units here. We've got meters per second going to miles per hour. What that means is for every 1 second, it takes 3 times 10 to the 8th meters. Well, it'll travel that many meters. And for every 1 hour, how many miles will it go? So here's our plan. We can't do this in one step, but we can go from meters to miles per second using this red underlined conversion factor. Then from that, we can convert from seconds to minutes, and then from minutes to hours, because we know that 60 seconds is a minute, and that 1 hour is 60 minutes. So this is going to be a 3-step process. Again, so take the number that you were given, 3 times 10 to the 8th meters for every 1 second, and put that at the beginning. Notice here that we do have units in our denominator because there was a divided by sign, in the number that we were given. Then we're going to use our conversion factor to go from meters per second to miles per second. Since meters was on top here, we want to put it on bottom in our next step so that meters and meters cancel out. Now our units left are miles per second. We can ignore the numbers till the end and just look and see that we're on the right track because we have this as our next step. Now here's where it gets a little bit tricky. We want to end up with units of hours in the denominator, but right now seconds are in the denominator. So now we need to convert the seconds to minutes. And we know that 1 minute is 60 seconds. So where will seconds go in our next step? Will they go on top or will they go on bottom? Don't follow this rule because this only works when you aren't starting with units in your denominator. If seconds are on bottom here, we want it to cancel out, we're going to put them on top in our next step, so that seconds in the denominator cancels with seconds in the numerator. 60 seconds is 1 minute. Make sure you put the 60 and the 1 in the right spot. And then do the same thing, noticing that we've got miles per minute, and we want to go to miles per hour. So minutes will go on top, so that it will cancel with minutes, and hours will go on bottom, and 60 minutes is 1 hour. Then you can type this into your handy-dandy calculator. So 3 times 10, or you can use the EE button, do second and then the comma to get the E, times 10 to the 8th, divided by, oh I don't know that number, 1609.3, times 60 times 60. Are we expecting a big number? Well, yeah. Light travels a lot faster than my car can, so whoa, that's a big number. I have it written down over here. That's a really, really big number, which we said is reasonable because light travels pretty fast. So, now we need to look at sig figs. Our given number at the beginning had just 1 sig fig, so our answer has to be rounded to 1 sig fig as well. The first number here is a 6, the next number is 7, so the 7 makes the 6 round up to the next higher number, which is 7. So it looks like we have 700 million miles per hour, or if you wanted to put that into scientific notation, you could say 7 times 10 to the 8th miles per hour. And again, that's reasonable because light travels pretty darn fast. Okay folks, well, one more problem we're going to do together. This one is even trickier. It may seem simple at first, but I'm going to have to walk you through how to do that with the cubed thing here. So this box here has a volume of 8 meters cubed. What is its volume in centimeters cubed? So our plan is to go from meters cubed to centimeters cubed. And you may remember that 1 meter is 100 centimeters. You might think that we could just convert directly from meters to centimeters using this, but this is meters cubed and centimeters cubed. And here's what this means. If you had a line that was 1 meter long, it would be 100 centimeters long. But what if you had a box that was 1 meter by 1 meter, just like a square? What would the area of that be? Well, you'd have to find the area by multiplying the length times the width. So it'd be 1 meter times 1 meter, or 100 centimeters times 100 centimeters. So that'd be like 1 squared, meter squared, or 100 squared, centimeters squared. Or if you kind of multiplied that out, 1 meter squared is 10,000 square centimeters. Oh, so we can see that a meter is 100 centimeters, but a meter squared is 10,000 centimeters squared. What about this cubed thing? So for that, imagine a box that was 1 meter by 1 meter by 1 meter. So 100 centimeters on each side. What would the volume of that box be? Well, 1 meter times 1 meter times 1 meter is 1 meter cubed, and 100 centimeters cubed is this. So we'd have to distribute the cubed in, and we'd end up with a conversion factor of 1 meter cubed equals, what is that, 1,000,000 centimeters cubed. You don't need to memorize this number, but you should be able to derive it, thinking about the fact that if you need cubed units, you have to cube the entire conversion factor, as you can see here. So let's apply this conversion factor to our problem. If we know the box is 1 meter cubed, we can put that over 1 to show that this is the number in the numerator. Then we'll take our conversion factor. You could either use this form here where you said, oh, well, I know a meter is 100 centimeters, so cube it all. Or you could write it with this longer form. It's going to give you the same answer. These are equivalent statements. So 8 times 1,000,000 turns out to be 8,000,000 centimeters cubed. It has 1 sig fig, as our original number did. So that would be our final answer. And that should make sense, right? Because if it's 8 cubic meters, it should be a lot of cubic centimeters, because centimeters are a smaller amount of measurement.